Hi folks, we're going to take a look at number 15a from the Unit 3 assignment. So they give us this function which has an unknown constant k, and they ask us to find the values of k such that f is going to have critical points. Okay, so if we're looking for critical points, we know we're going to have to work with the derivative, so let's start by finding the derivative of this function. Okay, so quotient rule, derivative of the numerator is just 2 times the denominator function minus the numerator function times the derivative of the denominator, which is just 2x since k is a constant. Okay, and here x squared minus k squared squared. So let's clean up that numerator. So 2x squared minus 2k squared, and here 2x, so minus 4x squared, and 4 and 2x is 8x minus 8x. Okay, let's keep simplifying. So 2 minus 4, negative 2x squared, then minus 8x, and then minus 2k squared. And we can factor out negative 2. Let's make things a little simpler here. So negative 2, so here we're left with x squared plus 4x plus just k squared, all over x squared minus k squared squared. Okay, and that's about as far as we can go. So in order for this to have critical points, well, we have to look at where this function is equal to 0 doesn't exist. Okay, but the only places where this derivative doesn't exist is when the denominator is equal to 0. But whatever makes the denominator equal to 0 in the derivative also makes the denominator equal to 0 in the function. So those would be points where there is no point, so you can't have a critical point. So those would not be included in our list of critical points since the function doesn't exist there. So the only other thing we have to look for is what makes this derivative equal to 0. Okay, so in other words, what makes this expression up top equal to 0. Okay, so we need x squared plus 4x plus k squared to be equal to 0, or we need this equation to have solutions. Okay, but given that this is a quadratic equation, it does not always have solutions. So we need to find what k values will allow this equation to have solutions. Okay, and we're going to use an old grade 10 trick to solve this, okay, because if we wanted to solve this equation, we could use the quadratic formula. And the only way for the solutions to exist is if that expression inside the square root of the quadratic formula is greater than or equal to 0. Okay, if that expression, in other words, the b squared minus 4ac, okay, whoops, not k, but we need the b squared minus 4ac expression in the square root of the quadratic formula to be greater than or equal to 0. When it's less than 0, well, you have a negative in the square root and you have no solutions. Okay, so this is essentially what it boils down to determine where b squared, which would be 16, minus 4ac, 4 times 1 times c is k squared, okay, is greater than or equal to 0. So in other words, 16 minus 4k squared greater than or equal to 0. And so what we have is a polynomial inequality, which of course we solve by factoring. So let's take out a 4. So we're left with 4 minus k squared. And so here this can be factored to 2 plus k, 2 minus k. And we just need to figure out when this expression is greater than or equal to 0, but since it's a quadratic, I'm just going to graph this, okay? And we know that the zeros are at negative 2 and 2. Okay, so remember, these are my k values. And we take a look at the function 4 minus k squared. Since the leading coefficient is negative, it's going to be a parabola going downwards. Okay, so the only places where this expression is greater than or equal to 0 is between negative 2 and 2 inclusive. Okay, so our solution here is that k needs to be less than or equal to 2, but also greater than or equal to negative 2. Okay, for these k values, the discriminant for this equation will be positive, hence x squared plus 4x plus k squared equals 0 will have solutions. Okay, so as long as k is within this interval, the derivative will be equal to 0 at certain x values. Okay, notice they're not asking us to find where it's equal to 0, okay, because that's going to depend on the choice of k, but these are the k values necessary in order for this equation to even be solvable. Okay, so again, just to recap, okay, since you're trying to look for critical points, work with the derivative. Okay, once you realize the condition needed in order to make the derivative equal to 0 is that this equation has to have a solution, and given that it's a quadratic equation, I worked with the discriminant to determine what conditions are needed for the discriminant to be greater than